next 30 minutes, you will master OOPs in Python, from classes and object to inheritance, polymorphism, and a real word design. If you are writing function, your code still feels messy. This tutorial will change the way you think about writing Python. Let's say you are building a fleet manager for delivery truck. So in procedural programming, it starts as simple. So let's build a basic way of writing Python code. So let's say this is code1.py. So for that you are going to define the variables. Let's say truck name is equals to truck1 and truck capacity 2000 kilograms, truck location, let's say warehouse A, and then you define a function that will utilize those variables. So drive truck name or let's say destination, and let's simply print right now the truck name is heading to destination. So if let's call this function drive truck name truck, let's say truck, let's send it to truck location, and if we run code1.py, so it says truck1 is heading to warehouse A. It works until it doesn't. Let's say you add another truck, so you want to track more info, let's say schedule, fuel, maintenance. So your variables become like a spaghetti. So this is where the OOPs steps in, not just to organize but to think like a system architecture. So this is where in Python you will going to learn about classes and objects. So let's start from scratch. And what is class? Think of it, it's like a blueprint for building object. Let's build a truck class. So now let's make a code 2.py, and in here we are going to define a class. So how to define that? You'll type class and then you say truck. This is the class name, and then you'll have to define the class initialization method, which is in the dunder init. It takes self as an argument and the variable that you want to define. Let's carry on the previous example. Capacity, location. Now we are taking these information from the user of this class, so we'll need to define variables and do the variable assignment. So let's assign self.name dot self.capacity as capacity, self.location as location. Now this is how, when you initialize an object, this will do the assignment work for you. Now let's define a function. Let's call it drive. So self dot destination, and we are going to print self dot name is driving from dot location to destination, and then we are going to update. Once the truck reaches there, we'll change their location to the destination. So that's how it works. And now let's do the usage. So let's define so if name is equals to main. Now we are going to initialize the truck. So truck 1 is truck. Let's give it a name as A, and its capacity is 2000 kilo, and it is in the warehouse. Warehouse A. So, and then this is the initialization step is done, and now we will send this truck drive to destination city center. Let's see if it runs. Code2.py. So see, it is saying a truck name is driving from warehouse A to city center, and these are the internal reference, whereas this is the outside reference. So you see this object has a memory. It knows its state, meaning where it has originated, and this is just the beginning. Now, as this is the basic oops class, next thing we are going to learn about the encapsulations, where the protection protect which is matter to you. Like encapsulation means keeping the internal stuff hidden. You don't want user directly changing the fuel level or say balance in your bank account. You give them access only through methods. So let's build another example. This example we'll name it as Encaps, short form for encapsulation. Let's now again create a class. This time let's make a bank account. Now again render init. It takes a self, and let's say an account opens with a balance. So balance. So let's assign self dot balance and balance. So what I did here, just notice the double underscore. It's not a single underscore. So this is a double underscore. You just keep a notice on it and see the usage. So let's say we make a function deposit. So it takes self and then an amount. and then what it does, it is going to increase the balance by that amount. Same thing, let's make a withdraw. Amount that they are going to withdraw. Now if the amount is greater than your balance, obviously you cannot withdraw that amount. So in that case we'll raise an exception, value error, insufficient funds, and if this is not the case, then we are going to adjust the amount from the balance. And let's make a also function that prints the balance. Get balance, it takes self, return self dot under balance. This is what we have done, the encapsulation, meaning you have only access through this function but not through the outside the class. So let's see any usage, then it will become more clear. Name equals to let's define the account, and let's bank account. Let's open an account with $1,000 balance. So let's do one thing, let me try to retrieve the balance directly. Let's see what happens. Hopefully you'll see an error. See, it says it has no attribute balance, but you can see it is present. So what it does, it has kept it hidden from direct usage. Instead of that, if you use the encapsulation, you will see you will have the access. See, 1000. Now let's make some withdrawal. Let's say 50, and then again print a balance, and then account deposit, let's make 1000, and then again print the balance. So it should become 950, then it become 1950. Let's see, this is what initial balance, we remove 50, then we added 1000. So that's how it works. Now next thing we'll need to learn about the inheritance and polymorphism. This is used when your code evolves. You know what's better than writing code? It's reusing it. So inheritance lets you extend the functionality instead of copy pasting. So let's inherit our bank account class. Let's make another class using your bank account class. So class, let's make saving account. This is a special type of account that inherit the bank account. It just has new functionality, which is apply interest self and interest. Let's calculate it. Self dot get balance, whatever be the balance, let's add 3%, 3. This is the interest. So self dot, let's make a deposit of that interest. Sorry, I think I have made a typo. Yeah. So this is the saving account which has another functionality, and see, I am using a function from the parent class. It's not present over there visually, if you can see, but actually it is present. So this is the power of inheritance. Now if I'll come here, and if I'll make it as saving account, everything remains same. Now what I'll do, account dot apply interest, and after that let's print dot get balance. So let's see if we are getting interest. Yes, so after the amount we are getting the interest. Now you can also see the polymorphism in action. So let's make two different types of account now. See, a account, let's make an array of bank account, normal bank account, initialize with 10,000, saving account, initialize with 1500. Let's say for account, in accounts, let's in both account, let's do a deposit. And if is instance account, if it is a special saving account, look, I'm checking here, so we will apply the interest, and once all of these things are done, let's comment out the code for now. We'll just print dot get balance, and let's see if it applies the interest. Yeah, so for normal it just added, and for the savings account it added, but it also gave us 3% interest. So see, with just one same calling we achieved two different things. Now they are, if you look, their calling is same, but the outcome is very different. This is polymorphism. So now that you have understood the basics of OOPS, the abstraction, encapsulation, polymorphism, let's build a real world OOPS program. Let's build a ride hailing app core logic. So let's get real. Suppose you are building a basic ride hailing system. We'll design class for driver, vehicle and rider. So let's make the code car.py, and let's first define the class of driver. Def under init, and driver takes name. What else? Driver takes license number. And let's also first define the structure for other class. Let's say vehicle, and let's define init their make and plate. And let's also define class ride. So def init. Let's say a ride needs to have driver and it takes a vehicle. So now you are seeing, if you get the sense, we might be giving this ride class two classes. So let's first implement the assignment is name dot license number as license number. Same thing here. Self dot plate is plate. Now let's see. So self dot is driver. Same way self dot vehicle is vehicle. Now we can define a function which says start self and it prints, let's use f string self dot driver dot name is starting your ride in a self dot vehicle dot make, and we can give the vehicle plate self dot vehicle dot plate. So now notice how these objects are composed. So this is called object composition, a powerful design a powerful design trick in OOPS. So if you see the usage, this time let's define the driver. So it takes name as, let's say, A, and plate name is 101, and let's make, after that we have vehicle, and vehicle takes make as, let's say, expn, just an example, and plate as 014, and then now we can make the rider class, initialize the rider class. So rider ride will take driver comma ph and then rdr dot drive, it's start. So now we should be using the variables from the composite one. So see, A is starting your ride, this is the make, this is the plate. This is a composite example. Now Now you'll need to learn one more concept which is called abstraction. This is what this does. It is essentially hiding the complexity with clean interference. So you don't need to tell engine how to, let's say, rotate. You just say start. That's abstraction and exposing only what's necessary. So let's make a class code, or maybe we can do it here as well. So let's make class engine. So let's say def start self print for now. Let's only print. Now let's define the class car. So let's say def init, and it takes self dot engine is equals to engine. And now let's define drive self dot engine dot start self dot engine dot start and print. So car is moving. So let me show an example. Let's say car underscore is carr, say car dot drive. Let's see what we get. So it says engine starting and car is moving. So this is what is called the abstraction. We took the abstraction of engine class in the car class. So the user only sees, if you are writing this car function, user only sees car dot drive. Okay, car underscore dot drive, but under the hood engine is kicking in, and this is what makes it clean and elegant way of doing it. So one more thing is, like, while writing the oops code, try to avoid those mistakes. So one is the God object. Do not try to cram everything into one class. Too much inheritance. Prefer composition over inheritance. And yeah, make sure that you are using the best practices. So what my final thought is, we just build a truck, bank, ride system and a car, all using oops, but now it's your turn. So try building a library system: book, member, library, add, borrowing, return, due date logic. Make it feel real. If this made object oriented programming finally click to you, drop a like, share this with your Python buddies, and subscribe for the next one. We are just getting started, and oops is not just how you write the code, it's how you design the world. Thank you.